Hello everyone, my name is Elisabeth Boadana. I'm the Scientific Director of the L'Oréal Paris brand. So welcome to the L'Oréal Paris Hub on hyaluronic acid. This year, I have asked our dearest independent board of dermatologists to join us with some of the L'Oréal experts to address the new trends in hyaluronic acid. We're going to go through the dermatologist gold standard in fillers, which is already becoming the new must-have for moisture and plump in cosmetic routines.
To open the symposium with the first talk, we thought it is very interesting to know or to re-summarize a bit more on the mode of action and the science behind hyaluronic acid, its function in the skin. Looking at the body content of hyaluronic acid, we know that over 50% lays in the skin. So we know that the production happens in the keratinocytes, so very superficial in the epidermis, but they're in the basal layer, and also in the dermis, in the fibroblasts. The synthesis is guided by the hyaluronan synthase, basically 3 enzymes. They regulate the endogen hyaluronic acid formation. Its production is critical for the physiology and also the pathology of our skin. So the degradation of hyaluronic acid physiology happens over time, and it happens in a enzymatic way by the hyaluronidase, and it also happens in the non-enzymatic way by free radical related degradation over skin aging over our lifetimes that triggers inducing our skin's aging and degradation, resulting also in degradation of the hyaluronic acid content in our skin. Hyaluronic acid does influence the keratinocyte differentiation. It does endorse cell migration, cell communication, cytokine formation. For example, hyaluronic acid goes high, kicks in to initiate the first phases of the wound healing. And it can also be increased by topicals. The retinoic acid does increase hyaluronic acid formation, and hyaluronic acid itself, and we'll see that in the last point of this talk. I'm now discussing with you the intrinsic features of hyaluronic acid. How does it work? So we all know that hyaluronic acid increases the viscoelasticity of the skin, or has a great impact on its viscoelasticity. It also moistures our skin because it holds water, not only obviously applied topically, but we all know that from our injection the patients we do inject hyaluronic acid with, it holds water multiple times its own weight. We know that hyaluronic acid is involved in many physiological functions of the skin. It does help in scaffolding against invading microbiomes. It's anti-inflammatory, antioxidant. As I said, it is very important in the early phase of wound healing. It has been shown that a small molecular weight does promote early inflammation in wound healing, and therefore kicks in or initiates the wound healing. We also know that small fragments of hyaluronic acid are angiogenic, so they form vessels. We also know that decreased levels of hyaluronic acid lead to scar formation. So hyaluronic acid is crucially important in the skin's physiology. And last but not least, again, we know that 100 to 300 kilodalton hyaluronic acid does increase fibroblast and keratinocyte proliferation and migration. We thought now it would be interesting to look at the receptors on the cell surface, which are the most important ones for hyaluronic acid. There, obviously, the CD44 is the most important one in terms of transducing signals from the cells outside to the cells inside into the cells. So hyaluronic acid, or the CD44 receptor, is involved in its synthesis, in its cellular uptake, the cell migration, cell communication, proliferation. And for example, it has been shown that in cultured keratinocytes, downregulating of the CD44 receptor inhibits the HA-mediated differentiation of keratinocytes and also lipid formations. This receptor is a very important one to understand hyaluronic acid's mode of action or its function. And just one other remark, in injecting hyaluronic acid, we know that CD44 receptor mediated functions lead to increased hyaluronic acid levels, even or stimulation of the formation of the endogen one, even after the filler is degraded. So it is a very important protein receptor surface communication organ or tool for hyaluronic acid. Okay, in the last paragraph, I wanted to just focus on the topical application of hyaluronic acid. It has been shown by Raman spectroscopy that hyaluronic acid, the topically applied one, can penetrate the skin via active transports. And then obviously we found different molecular weight hyaluronic acids that can penetrate the skin because the molecules are simply smaller. We know that it does hydrate the epidermis, but it does also stimulate the keratinocytes in their function, and also CD44 mediated, it can increase its own production. So at a certain level, the low molecular weight hyaluronic acid applied topically can already stimulate skin's function and result in a tiny bit, but a increased thickness of the skin. In the keratinocyte culture, it has this increasing of the skin thickness has been shown. The high molecular weight, the 1,000 to 1,400 kilodalton hyaluronic acid, will lay on the skin like a film to protect, to moisture the superficial surface of the skin without the penetration. This makes the skin more stable, increases the skin barrier function, and improves also the permeability of the aged epidermis. So we know by a lot of clinical studies that cosmeceutical products containing these two different molecular weight sizes of hyaluronic acid are very beneficial for our skin's health and at the end of the day also for its beauty. So thanks for sharing this moment with me, and we'll continue with our next talks.